All right, for those of you following the whole course, I'm going to move away from working with fractions for now, and in this video, I'm going to start thinking about introducing some elementary algebra into the picture. Now, by elementary algebra, I mean the study of basic mathematical operations, so addition, subtraction, multiplication, etc., with the addition of one or more mathematical variables. So you might see things or remember from high school things like 4x plus 8 is equal to 5, or 3y minus 50 is equal to z. These are algebraic expressions, and we use algebra all of the time in economics. Now, by variable, I mean a measure that can take on different values. For instance, we could have a variable that is a measure of height or weight, or an exam score. In economics, we're interested in lots of different variables. We might think about gross domestic product, GDP, the unemployment level, the price of a good, etc. All of these measures can take on different values. They vary. Now, in our mathematics, we're going to represent variables with letter symbols. For instance, we might designate H to represent a person's height, or W for their weight, S for an exam score, GDP is sometimes Y, unemployment U, and price P. And then what we can do if we have some variables that we're interested in, and if we think that they're related to each other in interesting ways, is that we can use our mathematical operations with our variables. So we use our algebra to describe the relationships between those different variables. So basically, algebra in economics becomes a really important tool for us for our modeling. So as an example, let's consider a demand equation. So demand equations relate a price variable, that's P, which is the price of a good, with the quantity of that good demanded, Q. And demand equations link these two variables in order to basically help us answer questions like, if I change the price of a good, what happens to how much of that good is demanded? So as an example, let's consider the following demand equation: Q is equal to 10 minus P. So this demand equation tells us that the quantity of a good that is demanded can be found by subtracting the price of the good from the number 10. So let's just imagine I'm selling oranges. If the demand for oranges is accurately represented by this equation, then if the price was, say, equal to 4, then P would be equal to 4. We could substitute P is equal to 4 into our demand equation, and we would find that the quantity is Q is equal to 10 minus 4 is equal to 6. We can check another price. If the price increased to 5, well, the quantity demanded, substituting that in, would be Q is equal to 10 minus 5 is equal to 5. Now, alternatively, we might be given the quantity, and then we would have to figure out the price associated with that quantity, and we can easily use our demand equation to do that as well. For instance, let's say that we're told that the quantity was 3, so Q is equal to 3. We could substitute Q is equal to 3 into our equation. We get 3 is equal to 10 minus P. Now, to solve for the price here, to solve for P, we could take away 10 from both sides. So we would get 3 minus 10 on the left-hand side and 10 minus P minus 10 on the right-hand side. On the left-hand side, that would be negative 7, and on the right-hand side, the 10s cancel out, so negative P, and that solves for P is equal to 7. We would just multiply or divide both sides by negative 1. Now, in this example that we've been working with, because that variable Q is isolated on the left-hand side, we would say that in this equation, quantity is being modeled as a function of price, or rather, the value of the quantity, Q, depends on what the value of P is. In this way, Q may be called the dependent variable and P the independent variable. So quantity is dependent on price. So we have two new concepts that are worth discussing. We have the concept of a dependent variable. That's the variable in our algebraic equations that are changing in response to. They are dependent on another independent variable, or variables if there is more than one. And then our independent variables, well, they're variables that are changing independently of the dependent variable. So the independent variables, they're moving around and affecting the dependent variable. And this designation of dependencies might be actually evident in the notation that you see in your text or notes. For instance, you might see this demand equation expressed like the following. So Q, open bracket P, close bracket on the left-hand side is equal to 10 minus P. Now here on the left-hand side of that equality, we have the independent variable P in parentheses next to our dependent variable Q. Now this does not mean that on that left-hand side that Q is being multiplied by P. Rather, this is just a way of notating our equations and our models just to make clear that quantity is being modeled as dependent on, or sometimes we say a function of the price. So this stuff on the left-hand side of the equality, it's just notation. And we can take this notation further. If we're talking about a demand function or a model of demand more abstractly, you might see in your notes or textbooks just Q open brackets, P close brackets. And if you see this, this just means, again, it's referring to, or we're talking about a model where quantity is being modeled as dependent on or a function of the price. So this notation is called function notation, and there is a lot of mathematical formality behind this that I am completely glossing over, so apologies to mathematics here, big sorry to maths. If you would like me to do another video on function notation or functions more generally, please let me know. I can put it as an appendix to this course. The point that I wanted to get across here, though, is just what this notation is communicating, and especially that it's not a multiplication on that left-hand side of the equality. And we can use this notation quite easily to describe more complicated models. For instance, let's say we had an algebraic function where costs C are being modeled as a function of quantity. They're dependent on quantity, the price of labor, that's W for wages, and R, the cost of capital, that's rent. It's a reasonable sort of model we might think about. And so if we saw this notation, C open brackets, Q, W, R close brackets, this just means that we're talking about a model or an algebraic function where firm costs are being modeled as dependent on quantity, wage, and the cost of capital, that rental rate. Now, we might have a more specific designation of what that algebra in that model looks like. So C might be equal to Q plus W plus R squared or something like that. But we can, and we also do, talk more abstractly about these algebraic relationships as well. Now, the last thing that I want to talk about in this video is just a little bit about interpreting algebraic equations. And there is lots to say here, and we're going to get into this more deeply over the next few videos. I'm just going to give one preliminary example of what we might look for, and that is thinking about ascertaining whether we have a negative or a positive relationship between our variables. For instance, from our demand equation that we were looking at before, I can actually see straight away that there is a negative relationship between price and quantity demanded. And that's evident from the negative sign in front of the price variable. And hopefully you can gauge that the value of Q, the value of the whole expression, that whole right-hand side, as price increases, that value will decrease because it's 10 minus the P, right? So as P gets larger, 10 minus P gets smaller. And we actually saw that quite concretely before when we looked at actual prices. When the price was equal to 4, quantity was 6. When the price increased to 5, quantity decreased to 5. So price increased and quantity demanded decreased. That's a negative relationship. And this is actually one way to gauge the nature of the relationships between our variables. If you can't see it straight from the equation, just plug in actual values into our independent variables and see what happens to the dependent variables. Now, as per usual, we can be comforted in the fact that the more practice we have, the more equations we see, the more economics that we do, the better we will get at it. All right, so that's really it for this video, though, on introducing you to the use of elementary algebra in economics. There's actually quite a bit here. And so just to review, in this video, we defined elementary algebra. We looked at an example from economics. We talked about independent and dependent variables. We talked about function notation, and we talked a little bit about interpretation. If you have any questions at all, please comment below or you can email me. I really hope these videos are helpful to you. If you would like written notes to help you on your journey, you can visit my store below. The notes include lots of practice questions with solutions, which can really help solidify your understanding of the material. If these videos have helped, please like and subscribe, comment below, share, all of that. It all helps. Any feedback also is welcome. Thanks everyone. Hope you guys are having a good one.